Okay, let's move on to the next phase, the potential application of motion sickness model to automated driving. This slide shows the change that occurs in AD and its potential risk of motion sickness. So what is changed in the driver side includes the fact that drivers become passengers, which lead to the loss of control and changes in the posture and the body movement. And its potential risk factor of motion sickness includes decrease in motion control ability and decrease in visual information and decrease in anticipation of upcoming information such as road geometry ahead, as well as effect of head posture on motion sickness. And another change is increase of non-driving related tasks such as reading and working on a laptop PC. And the risk factors are almost same, but the additional thing is, yes, the change in head posture by engaging in non-driving related tasks. And the changes in the vehicle side includes, yes, a vehicle control system should be changed. And yes, potential risk is that the vehicle motion could be dramatically changed. And also, yeah, vehicle design might be changed, such as window size and introduction of in-vehicle devices. And the potential risk includes changes in the visual information and sensory conflict. The keywords of the risk factor is listed here. Changes in the body or vehicle motion and the visual information, and increase in the sensory conflict, and decrease in the anticipation. The computational model of motion sickness should have the ability to describe such phenomena, and I believe that some of them have been already included in the model. Okay, so let's talk about what kind of efforts we can make to reduce the motion sickness. For motion control, targets are motion planning in the vehicle control for the lateral and the longitudinal direction, and active suspension system, and lean control for the narrow vehicle. And for vehicle design, we can take some action for motion-related design, such as including suspension system and visual environment, such as window size and location of monitor. And for in-vehicle device, visual display, some effort can be made for visual display or other devices for non-driving related tasks. Okay. Now we have computational model of motion sickness to quantify the motion sickness. So the decreasing the motion sickness can be dealt with as a model-based optimization problem. Okay. Okay, so let's discuss about why motion sickness should be considered for ADS motion design. For manual driving car, the human driver intuitively considers the ease of driving and degrees of motion sickness. But the vehicle motion pattern of ADS can be changed dramatically, so the motion sickness should be explicitly considered. Okay, now we have the computational model. So given that the model of motion sickness, the optimization technique can be used. Due to lack of time, I'm omitting detail, and I wanted to just raise two examples of the motion design using the model of motion sickness. The first one is this one, velocity profile generator. The velocity profile for vehicle navigation to minimize motion sickness can be performed by using the model. And the second one is a trajectory generator. Yes, real-time vehicle control to minimize motion sickness, such as lane changing or something, can be also performed by using the motion sickness model. Again, as I mentioned before, given the computational model, optimization technique with the model can be used. As we see so far, the computational models are promising tool to build comfortable automated vehicles because the model facilitate to estimate motion sickness and to turn the effort to reduce motion sickness into optimization problem. But we need to aware of the limitation that the models are always under construction, and the phenomena the model can capture are very limited. Therefore, like any other scientific study, this cycle shown in this figure is very important. Try to apply the model to build the countermeasure, and the result is fed back to the model. So one more thing that we need to aware of is the fact that the data of motion sickness is very important, but not easy to obtain. Therefore, researchers need to collaborate to tackle these important and challenging problems. Thank you very much for your kind attention.